Hi, I'm Michael Woods, Chief Scientist at the Asian Turfgrass Center. This is a presentation on systematic improvement of course conditions. This is a talk that I gave at the ATPI conference in Galway last week. And I'm going to try to blast through these slides pretty quick to talk about, or just to tell people who were not there, what I talked about. This is something that John Scott always asked me to do, and kind of in his memory, I feel that it's something that I'll try doing more often, to share the things that I've talked about. And if you did happen to be at that presentation, you can watch this as a refresher. This is the topic about systematic improvement of course conditions is about how we can get the type of system implemented at a facility where we can actually improve things based on what's happening, not based on the textbook, because the textbook can only get us so far. You can't actually take the textbook information and apply it to get the exact answer to how you should manage the turf. There are things that you need to evaluate with how the grass is performing and then adjust them. In this presentation, I described those, about all of the things that I think are especially useful to measure. And I start off by thinking what we're really trying to, what we are trying to accomplish is having soil properties that allow grass to grow and the surface to perform. So the soil properties need to be correct. And if we have those soil properties, we can then start to have grass that's resilient to the necessary maintenance. And if we have grass that's resilient to the necessary maintenance, we up with desired playing conditions. So there's three levels that we need to have. We need to have some consideration of the playing conditions, and then we also need to consider what we need to do to have grass that's resilient to the maintenance that's necessary to produce those playing conditions. And we also need to have soil properties that will support that grass and the type of surface that we need. When we're doing that, I like to use this type of system, and it's something that I've seen used to great success by many facilities around the world, and I wanted to share it, and I did in this presentation. And I've divided what we should know into three categories. We've got the surface performance, which I'll start with, then we've got the grass measurements, and then we have the soil measurements. So starting with the stimpmeter, which is quite useful because grass is mown short. It's mown at 3 millimeters, only the purpose of having a good green speed, to have a putting surface where the ball will roll well. And if we didn't need to have green speed with greens that are mowed at 12 millimeters, half inch, useful for me to measure the stimpmeter. I recommend doing it at least once a week. This is a year of stimpmeter measurements from Keio Golf Club in Japan, and these were measured on the days when the whole location was changed. So it's not every, and it's not every Friday, but at a minimum, I think Fridays are a good day because it comes before the weekend. At minimum, I would recommend measuring once a week. If you do that, you get 52 measurements, unless the course is closed or under snow for part of the year. And if you do that, you'd have 52 measurements. You can track how it is over time. And it turns out to be quite useful to measure the stimpmeter because the work can then be adjusted to achieve the desired conditions. So for example, in December and January and February, when the zoysia grass is dormant on those greens, without mowing, without rolling, the speed is over 11 feet with absolute maintenance. So it makes it easy to see that if the green is at speed. If that speed is fast enough, there is no need to do any additional work. And one can then see how it changes through the year, and the work can be adjusted. I used to think that this was sufficient. I used to think that it was sufficient to only measure the stimpmeter, because I thought that firmness was pretty easy to assess, and I still do. But people ask about it, and so I'm going to have some comments about greens. And I realize that it probably is a good idea just to note whether it is at an acceptable level or not. There are various tools that one can use to measure firmness. From left to right, we're looking at the ball bearing drop that's used by the PGA Tour. I absolutely despise this particular measurement. Although it's simple, I find it very, very difficult to get a reading. If there's any sand on the green, I also find it difficult. I just find it difficult to use that particular setup. The Clegg hammer is my favorite. It's the fastest, it's easy to use, and I really like it. The True Firm from Spectrum Technologies is something that I've used, and it's pretty good, but I find it not quite as consistent, and a bit slower to use, a bit more difficult to use than the Clegg hammer. Then there's a Yamanaka tester, which is a type of cone penetrometer, I believe, and that's the standard device used to measure green firmness in Japan. And those are ways to measure green firmness. But I think that's useful for research or for very specific uses, maybe for assessment or something like that. But I think on an everyday level, isn't it acceptable to just put green firmness into one of three categories? You could just note, are the greens too soft? Let's say too soft gets a label of 1, or gets a integer assessment of 1. And the greens are at an acceptable level, that could get a value of 2. And if the greens are too firm, that could be a rating of 3. So you could just code it as 1, 2, or 3. The greens they're either too firm, they're fine, or they're too soft. I struggle to understand how turfgrass managers cannot make that assessment. I think everybody can make that assessment, and if you can't make that assessment and need a meter to be able to make that assessment, I would be surprised, because I think I mean, of course the meters give a lot more precision, but if you just want to assess the firmness level and say, are we fine or not, then that simple 1, 2, 3 rating could work. There's another thing related to playability, the smoothness and trueness of roll, that I also didn't start recording until a couple years ago, because I assumed that when everybody is putting a ball across the surface, or watching balls roll across the surface, or doing a stimpmeter test and rolling the ball across the surface, I had assumed that when people do that, they also look at how the ball rolls and they determine whether it's acceptable or not. Well, it came to my attention, and I started realizing that even though greens are sometimes rolling 10 feet, the ball is bouncing all over the place. And when the ball is bouncing all over the place, even though the green speed might be rated acceptable, the ball roll is quite horrid. And in fact, I talked to a golf professional at one club, and he told me the greens just had something undefinable that wasn't quite right with them. And I was rolling the ball, and it was rolling 10 feet, and there was just chatter all through the roll. And I gave those greens a rating of 6 on the bobble test, which is what I recommend doing for an assessment of smoothness and trueness of roll. I think it actually is useful to measure this. There's 5 different ways to measure it. I've explained this in another video, and in a blog post. I can put a direct link to that in the description. There are meters that one can use, and a very simple procedure called the bobble test, which I quite like, which rates the ball roll on a scale of 1 to 10. And people say, oh, this is going to be subjective. But actually, it's not subjective because there are certain criteria that one evaluates for a particular score. For example, the definition of a rating of 6 is that chatter dominates possibly single bobble events in some snaking. Now let me explain what chatter is. Chatter, well, let's start with bobble. I call this the bobble test, and bobble is vertical deviation where the ball leaves the ground. A bounce, a bounce where you can see that the ball actually leaves the ground. Chatter is vertical deviation from a true roll where the ball is just bouncing up and down, but it doesn't leave the ground. So you'll see that sometimes the ball will chatter all through the roll, and sometimes the ball is rolling along nicely and it'll have a little chatter event, and then it rolls along smoothly some more and then has another little chatter event. That's what chatter is. And snaking is when the ball moves left or right of the desired line, of the intended line. If it was a true roll, it would continue rolling on the path that it's rolling on, unless that is, of course, there is the natural break of the green, or the borrow of a ball as it is affected by gravity. That is not snaking. Snaking is when the ball deviates from the line that it should be on. And those are the three possible things that can occur: bobble, chatter, and snaking. So for example, to go back to that 6 rating, there are possibly single bobble events with a 6. So the definition for a rating of 8 is that the roll is predominantly smooth, but with single isolated chatter events and minimal snaking. You can see that there's no bobble there. And if the ball bobbles, if it bounces and leaves the ground, I automatically am going to give it a 6 or below. And one looks at the various intensity or whether these events are happening entirely through the roll or if they're isolated events, and we can see what score it should get. Chris Trittabaugh at Hazeltine National Golf Club has done a great series of blog posts, and he shared this post in it about a year of bobble tests. I will put a link to those blog posts also. He shares the ball test ratings for the 2021 season at Hazeltine National Golf Club, and you can see with those green lines, which I'd like you to look at, the average daily bobble test score starts off at about 8 at the start of the season, and with mowing and rolling it goes up to above 9. And then in May 11th, there was a heavy sand top dressing event that dropped the bobble tests down to about 6.5 or 7. And that is partly because of the sand, and also so it's a direct effect of the sand, and it's also because less mowing and rolling can be done when the greens are covered in sand. And it took 9 days to get back to a daily average above 8 after that top dressing event. And then the bobble test score cruised above 8, which is almost perfect, 9, which is basically perfect. It cruised at that level all the way until August, when there was a cultivation, and that dropped the bobble test back down to 6, 7 again, and then it crept back up above 8 after a couple of weeks. So you can see that as we do disruptive maintenance and put some holes in the greens or put sand on the greens, it can lead to disruptions in the roll. I used to think it wasn't necessary to measure that smoothness and trueness of roll because I thought it was captured by the stimpmeter measurement. But as I saw more and more places that weren't really having the type of smooth ball roll that I wanted, that I expected, I decided it might be useful to assess that. And I think it turns out to be useful to assess, as Chris Trittabaugh has done. It's useful to assess the effect of maintenance practices and try to manage the maintenance practices that do disrupt the roll so that we can produce surfaces that are at a higher standard for the most number of days in the year. Those are the three surface performance things. Meter to me is the key thing to measure. We want to do the least amount of work to get the desired green speed. I don't know that we necessarily need meters to assess green firmness, but it's useful to document that the greens are at a acceptable level of firmness, or to note if they're too firm. And one could then take steps to adjust the grass or the soil to deal with that. And then I recommend doing the bobble test, or use a meter to measure it to assess the smoothness and trueness of roll. We move on to the grass measurement. Clipping volume is something that I think is really useful, because we're looking at how much the grass is actually growing. And all we have to do is take the clippings that are collected, measure the volume, divide by the area from which the clippings were cut, and now we know the clipping volume. From that, one can look at a number of things, such as the effect of plant growth regulators, the effect of fertilizer treatments, when the grass is growing at an optimum level, and what that optimum level actually is, and various other things. This chart is clipping volume from Seashore Paspalum in Hanoi. In the wintertime, the green speeds are quite fast and the clipping volume is quite low because it's cold. And then the clipping volume goes up through the spring, then it drops for a aerification event when the greens were not mowed, and so on. One can see history of the grass growth through the year by looking at the clipping volume. When one knows the clipping volume, it's also possible to estimate the nutrient harvest, and one can look at differences between different mowers. And when the clipping volume is measured on all the greens, one can also look at difference in growth from green to green. So there's like a unlimited number of things that one can look at with clipping volume. It takes about 30 seconds per green. If you've got a mower, a walking mower, I think it takes about 90 seconds per empty if you have a triplex mower. A little bit of time, a lot of value. I've even heard Eric Johnson from Chambers Bay says that it can help reduce weeds, because instead of the operators dumping the clippings in some area away from the greens, instead they save the clippings and they measure them and then put them in the utility vehicle. So they're not taking them out and dumping them on the course. So that reduces the spread of weeds, and it reduces the increased water holding capacity, and then weed invasion that can occur in those spots. I also think it's essential to know the nitrogen application rate. I know most people are keeping track of that. I think it should be on the top of turfgrass managers' heads. So if I like to say, you know, if today, when I'm recording this, it's March 13th, I believe. If I went to visit a golf course today, I would like to say, how much nitrogen have you applied this year? And I would like the turfgrass manager, the golf course superintendent, to be able to say, since January 1st, we've applied, for example, 2 grams of nitrogen per square meter. I think it's useful to keep track of how much nitrogen has been applied. I think in most parts of the world that's common, but I know there are some places where people don't really pay so much attention to this, and I find it useful to know the nitrogen application rate. In addition to nitrogen, of course, keep track of the phosphorus, keep track of the potassium. These are fertilizer records for a golf course in Japan, where there was no phosphorus applied, and 12 grams of nitrogen and 3.9 grams of potassium over the course of a year. When you do that, you can look at how your soil test would be expected to change. You look at how the grass has performed, and it makes it possible to make adjustments that are optimized. Again, we're talking about things that can be measured and then adjusted to go beyond the textbook and find out what works the best for any particular facility. I also think if you do use plant growth regulators, know the application rate, the timing, and the effect. Really look at that carefully, because it can be difficult to visually assess the effect of plant growth regulators. So it's useful to use growing degree day models. You can get those. Those are built into the Greenkeeper app. There are, I believe, some other services that try to do this, but you can look at some of the research by Bill Kreuzer and some of the growing degree day models to see how those work, and you can calculate how the effect of the growth regulator application is expected to change over time. This is important to avoid over or under regulation when using those types of products. Clipping volume is useful for that also, because when you measure the clipping volume, you can see if the grass is responding in a way that you would expect. Then we can move on to the soil measurements. There are a few of these. I think it is very important to know the soil water content. You can use meters for this. There are, of course, the portable meters like the Pogo or the TDR or the Theta probe. Those are quite useful. I think in-ground sensors like SPIO, the Soil Scout, I think Toro has a Turf Guard sensor. Those types of in-ground sensors I really like because they're measuring all the time. And so if you have a chance to use both, that would be good. But even if you don't have meters, you can still estimate what the soil moisture content is by having some idea of the field capacity, having some idea of the will point, and having some idea of the evapotranspiration. In fact, I used to do this when I was a golf course superintendent at Habu Country Club in Japan, and we didn't really use a soil moisture meter. This was 22 years ago. What I did is kept track of when the soil was at field capacity, and then I subtracted the amount of water loss expected from evapotranspiration each day. And from that, I was estimating a daily soil water balance and estimating when I would need to irrigate again. So I always had some idea of what the water content was in the soil, even though I wasn't using a meter. I think it's useful to think in those terms because one can then optimize the irrigation and optimize the playing conditions in the turf. I think it's also useful to know the soil nutrient content. By measuring the soil nutrient content over time, one can see the effect of fertilizer applications. All you have to do is take some samples, send them to a laboratory, interpret the results properly. I recommend interpreting the results by MLSN. If you do that, you can optimize fertilizer and make sure that you're only applying the nutrients that are required. I also think it's important to know the quantity of sand applied. I've been surprised when I ask this question of turfgrass managers, how many people cannot give me an answer. I ask, how much sand did you apply last year on a purchase? And people say, oh, I'd have to go look that up. I'd have to go make some calculations, or, oh, I should be keeping track of that. Now, some people know, some don't know. I recommend being one of the people who does know, because if you know the quantity of sand applied, it's a lot easier to make adjustments to optimize the conditions, because sand is applied for a reason, and it's nice to know if that objective of applying the sand is being achieved. And sand is expensive, and sand is disruptive. I find it useful to know the quantity of sand applied. When the sand is applied and one knows how much has been applied, it can then be compared to the total organic material testing, the OM246. I recommend doing this also. The total organic material is not the same as soil organic matter. Soil organic matter is something that you do on a nutrient test. It's a tiny bit of homogenized soil and organic matter that's been passed through a sieve. All the thatch is taken out. That's soil organic matter, SOM. The OM246, the total organic material, is at specific depths. The entire sample is tested for total organic material. In that way, one can measure the thatch, the rhizomes, the stolons, the roots, and the humus, and the soil organic matter. And by looking at how that total organic material changes over time, it is possible to optimize the sand top dressing and the scarification and the nitrogen supply, the growth rate, a number of things. These are all kind of linked together. We look at the clipping volume, we look at the nitrogen rate, we look at the sand top dressing. We can look at how the organic material changes over time at different depths. And the work can then be systematically optimized for a particular facility. Remember, we're also measuring the results. We measure the results in terms of the green speed, in terms of the bobble test, the smoothness and trueness of the greens. By measuring all of these things, it is a nice system. And let's see, there are 10 of them in total. I think some people are already measuring some of these, already recording them. Sometimes you're taking note of it, I'm sure, but not really keeping track of it, not writing it down or inputting it into a some type of tracking software or spreadsheet so that one can go back and look at those data later. You can do only one of these. I'm sure that doing only one of these and checking it over time and adjusting it will lead to improvement in course conditions or improvement in the efficiency of the work that's done to achieve those course conditions. One can do only one of these, or do two, or do three. But if you can, and I don't recommend like just jump in and do all 10 at once, but do one, and after you've got that figured out, then add in more and more. If you can do all of these, I think it puts turfgrass managers anywhere in the world in a very powerful position to be able to control the desired playing conditions, to control the grass, to have grass that is resilient to the necessary maintenance, and to have soil properties that allow the grass and the surfaces to perform. For me, this is a very logical system, and it allows us to take that turfgrass textbook information, that starting point information, and then apply it and adjust it at any golf course in the world in order to get optimized playing conditions. There is plenty more information about this turfgrass topic and all other kinds of turfgrass topics at my website, asianturfgrass.com. That is the presentation on systematic improvement of course conditions. I hope you found that interesting. You can always reach me through my website if you have any questions or comments about this. And that is something that I've also discussed with some friends in the Flying Blind video. In that one, I just talked about 8 things because I did not include the firmness and the bobble test measurement. So that's something that I'll also put a link to, and you can check that out. Thank you for watching. I'm going to try to record some more of these, so I'll be interested if you have any feedback about these screencasts, and if you think it's useful, please let me know. I'll be happy to hear either way and try to improve them so I can make it even more useful. Thank you for watching.